What is that one more step? You have to clean it up. You can't take square roots from a difference, right? You have to move forward to the other side. How many solutions will you get? Exactly. X plus 4 equals? Careful.
2.
That's why I asked how many solutions. So you cannot say 2.
Oh, -2, +2.
Excellent. Excellent. Well done.
Can we just put the plus and minus, or no, we can't do that?
Yes, we did.
Oh, okay.
Yes, we have to. Yes, we have to. Very good. So this is x equals -4 plus or minus 2, and we have to separate it like we did before. So, what now? -4 minus 2 is -6, -4, and or -2. And the solutions are then? Right.
And we put -4 because we were replacing it with the.
I moved 4 to the other side.
Oh, okay.
I have
Right.
to.
You did.
Yes,
Okay.
when we
I
move
see
one
it.
turn from the other side. It was so funny when you asked me if I'm okay. I'll tell you a quick story, just 30 seconds. I don't like to talk about myself, especially not waste your time in class, but quickly because it was funny. I got sick on a Tuesday at Arnold about 4 weeks ago, 3 or 4 weeks ago. So they called the paramedics and so on and so forth. They canceled my class, the evening class. Now I have another class to make up. So I think I had some sort of bacterial stomach. I didn't have any symptoms, but I was dizzy and I couldn't stand, and it was something weird. So anyway, so they canceled my class and they called everybody. Don't come. It's 5 o'clock for the 7 o'clock class, don't come. So they were informed. So one of my students, I got to my car, 10 minutes, 5 minutes driving home. She calls me and says, she was in my class before, a different class. She says, who are these people telling me that you're canceling class? You never cancel class. I don't believe them. I have to call you. And I said, yes, Maddie, I'm sick. They sent me home. She said, okay, then. She says, I'm going to keep you on the phone till you park your car. It was amazing. So like you, are you okay? What's happening here? Thank you. I appreciate it. Good. Number 5. What is it? Of course. How do I get the y-intercept? Good. So f of 0. Let's do this together. Let's do this together. 0 plus 4. 4 squared minus 4. Excellent. 0, 12. Now see, the only problem here, I shouldn't even say it's a problem. When you plug in 0, it was easier with the other one. Here you had to think, you had to calculate, but you cannot have everything good, right? It has to be something that is less good, right? Here, the advantage is that the vertex is very nice. I don't have to do anything. No calculations are required. But when I calculate the y-intercept, I have to calculate a little bit. Okay, 6, 7, and 8. 6, 7, and 8. What is 6? Is axis of symmetry. And the axis of symmetry, let me refresh your memory. The vertex is -4, -4, not -v, -4. Axis of symmetry is the vertical line going through the vertex, and we are talking about the position. We're not talking about the altitude. We're talking about position. X equals -4. That's the vertical line, x equals -4. Does this function have a min or a max again? Okay, the mean value is, you have the graph in your heads already. I know you already pictured that. -4. And the range, you already have it. We already graphed it. Correct. See how much, remember when we talked about transformations, I said, can you live without transformation? Yes, of course, quite well. But look how easy this is to understand this graph now by simply going back to simple plane x squared. We graphed it without even graphing it, right? So we start with the vertex, like always, -4, comma, -4. Bless you. We continue always with the axis of symmetry, which is not part of the graph. We continue with the x and y intercepts. And 0, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. And try to make it as symmetric as possible. I promise I'm not going to look at it with a magnifying glass, because I'll have to look at mine with a magnifying glass. So pretty similar, pretty symmetric. So if somebody graphs something like this, then I know the student has not studied, right? So this is pretty symmetric, not perfect, far from being perfect. So this is f of x equals x plus 4 squared minus 4. How do you feel about this second example now? Better? And you will have all this information. I will ask you step by step. Okay, now I would like us to see an application of this model. Okay, we studied this function. We graphed it. Okay, so what? Show me where it's applied. Here's an example. Imagine that I have a ball in my hand, and I am throwing the ball upward and outward like this. Just follow the trajectory of my marker. What function is this? Yes, right? A parabola, right? So let's look at an example in which we are going to use this model. On page, the quadratic model. On page 361, let's illustrate, let's say with 60. Let's read the problem. A ball is thrown upward and outward because if I do this, it's a totally different story. Right? If I do this, that's not a problem. But if I do this, that is a problem. Okay. And the function is given to us as f of x negative 0.8 x squared plus 3.2 x plus 6. The moment I see this, here's what goes to my mind. No matter what they are asking me, the function will have a max or a min. First of all, it's quadratic, so it's a parabola. So it either has a minimum or a maximum. Which one is it? Right. Why? Right. But also remember the terms have to be arranged in descending order. Because if they're not arranged, so if I arrange it differently and you said, oh, this is a. No, it's not a. A is the coefficient of x squared. So be very careful in descending order. Okay. So here's the first question. So first of all, I have to write, before I look at the question, I have to write what they represent. X is, y, or f of x is, in feet, both of them. X, it says the horizontal distance. Horizontal distance. And f of x, both in feet, is the height. So if I want to graph this function, obviously, I already pictured it for you. I'm here standing 5'5". Maybe this is a different person, whatever, or a different height. But doing this. So that's what it is. Eventually, the ball will hit the ground. So I'm here. I'm throwing it up and outward, and it reaches a maximum, obviously, at some point. So this is the max height. This is how far from me the maximum will be. And this definitely is how far from me the ball will hit the ground. Yes. So this is the maximum height. This is how far from me it happens. And this is how far from me, from where I stand, the ball will hit the ground. Now let's read what they are asking us to do. What is the maximum height, of course, of the ball? And how far from where it was thrown does this occur? So what am I asked to find? Really? I'm asked to find the, and how is it called? Of course. They can't ask for anything else, right? The vertex. So what are the coordinates of the vertex? How do I find the vertex? How do I find the x coordinate first? No, we shouldn't go back because we already know it's coming from the quadratic formula.
Negative b over 2.
Ah, yes, exactly. Indeed, negative b over 2a. So negative b over 2a for this ugly function. Negative is from the formula. B is excellent. And 2 times a is negative 1.6. Very good. So how much is where the maximum occurs? This is just the position of the maximum. This is not the maximum. I can't find the y coordinate before I find the x coordinate, right? So how far from me will the maximum be attained by the ball? 2 feet away. Excellent. So indeed, 2 feet away. Two feet. And this is 2. And this is 2. But now I want to determine the maximum height. What do I do to determine the maximum height? Exactly. This must be f of 2. Negative 0.8 multiplied by 2 squared, which is 4, plus 3.2 multiplied by 2 and plus 6. So please tell me what you get. Impossible. Impossible, right? Why is it impossible? Because it's a maximum. I throw it up in here, the answer cannot be negative. If I solve an equation, not if I plug it in. If I plug it in a function, everything counts. I can't disregard anything. But if I solve an equation, I can multiply both sides by -1. I can divide both sides by -1, whatever. So let's go back together, please, right here. Ready? So negative 0.8. Oh.
Is it 4?
Negative 0.8 multiplied by 4 plus 3.2 multiplied by 2 and plus 6. And the answer is 9.2 feet.
Oh, that's what you wanted. I thought you wanted the.
Is that okay? Okay, we had to plug it in back in the function.
Yeah, no, I get that. I thought you just wanted. I thought you wanted the step before that. Like
Don't we have to square it though?
I'm sorry?
Don't we have to square it?
I said 4, right? Yes, I have to.
Okay.
Yes.
Okay. I just-
9.2 feet. 9.2 feet. So this is 9.2 feet. Final question. How far does the ball travel horizontally before hitting the ground? What are we asked to determine now? This one, right?
Right. Yeah.
What does this represent for this function?
This is
X intercept.
Exactly. Indeed. This is an X intercept. So how do I find the X intercepts? Very good. So negative 0.8 x squared plus 3.2 x plus 6 equals 0. I recommend, let's say it again. Plus 6. Yes. I recommend let's clean it up. And what I would like to do is, if you allow me, multiply by negative 10. 8x squared plus, not plus, minus 32x minus 6 equals 0. Yeah, you're right. I should be careful with my numbers. At this point, honestly, I will divide both sides by 4 to make it as easy as possible. But you can say you're going to plug it in the calculator. Why do you simplify so much? Because I like that. So let's divide by 4. 2x squared minus 8x minus 15 equals 0. This is easier to work with. Do you have to simplify it fully? Let's do this together. Let's put it in the quadratic formula, and then let me show you how to put it in the calculator. I know we did this before, but let's do it again. X equals negative b plus or minus b squared minus 4 times a times c. Since c is negative, I'm going to change this into positive to make it easier, not have too many parentheses in there. Over 2 times a. Is this okay so far? Are you with me, everyone?
What part of this are we doing?
We're solving this equation with the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, but this is negative, so I change this into positive so I don't have to put too many parentheses. It's not a mistake. I just try to make it simple, if possible. So let's put this in the graphing calculator. Ready? Don't forget parentheses around the top. Left parenthesis, 8 plus square root. I don't trust these. I know your calculators are more sophisticated than what I'm used to as a calculator. And you may not need to put parentheses, but I have to. Okay, plus 4 times 2 is 8. 8 times 15, close the parenthesis. Go outside and put another parenthesis and divide the whole thing by 4. 5.39. Also remember there is another answer in which I go back and overwrite the positive at the beginning to a negative. So I got two solutions. One is x equals approximately negative 1.39, and the other one approximately 5.39 feet. So let's go back to our graph and tell me, where is this negative 1.39 on the graph? Here's where it is. This one. But who cares about it? We don't. But what I do care about is this. What is this? How much? How much?
5.
Exactly. 5.39 feet. So when I throw up and outward a ball that follows this model, it goes to a maximum 2 feet away from me. That maximum is 5.2. And eventually will hit the ground at 5.39 feet away from me. Any questions on this problem?
What, is this 3.1?
Yes. Quadratic functions. Yes. Any questions on this problem? Any questions? Go ahead, Sharice. Anything?
I don't have it.
So for that negative 10, you just plug that in just to make it an easier problem to work with?
Very good. So first of all, if you're asking me to solve a quadratic equation, I will never ever solve one with a negative leading coefficient. I can't factor. I don't want to put negative in the denominator of a quadratic formula. So I will always clean it up as much as I can. If I can avoid decimal numbers, I should. Why? Because sometimes when I write, I may not see that dot, and I may change it into 59 instead of 5.9. So If I can simplify, I will always simplify as much as I can, as much as possible. And it would be easier to plug it in. So I plug in integers versus decimal numbers and a negative here that will make this one negative. And what if I forget to put in the graphing calculator? Then I will get negative, this one I will get 1.39 and this one negative 5.39. So it's very easy to make a mistake with these negatives. So I recommend when you solve a quadratic equation, even if you factor, even if you use any other method, always keep the leading coefficient positive. Because if this is factorable, and you will not factor with a negative leading coefficient, it will be more difficult. Any questions? Very good. Anything else? Anything else? Do I get the idea of how to graph these functions and the steps that we need to, and how to find the vertex when we are asked to find the max or a min of a function? Yes? Any questions? Charisse, are you feeling better?
No, I thought I could help something.
Which part is not clear?
I'm just really not retaining any of it. Right.
Which one?
It's this.
Do you have some time after class to spend with me? Do you have an idea where to go back to right now?
Probably because I don't understand transformation, so.
Oh, on the
It makes it
previous
difficult.
on the previous function, you mean?
Yeah, that's probably.
Oh yeah, we can sit down and talk about that. I thought it was, but what about this one? The last one.
I mean, as long as I write the formula down before I start a test or something, I'll pretty much
Sure, of course.
be able to
Yes,
put that in.
yes, that's not a problem. Okay. Well, so let's move on to section 3.2, which is a little bit more involving. It's about polynomial functions. And you can say, or you can suggest, and I will have to agree with you, but do you talk about linear? Isn't that a polynomial function? Yes, the easiest first degree. What about quadratic? Isn't that polynomial? Yes, it is. Degree 2. Well, when we really talk about polynomial functions, we mean third, fourth, fifth, and so on and so forth degree. This is what we really mean by polynomial. Although linear and quadratic are also polynomial functions, of course. So now here's the next question. Why do I need this? Why do I even think of the higher degree, third, fourth, fifth, sixth, and so on and so forth? Here's why. You may encounter a model like this. You cannot fit a linear function through here. You cannot fit a quadratic function through here. You may encounter a model like this. You cannot fit a quadratic function, it doesn't work. You cannot fit a linear function, it doesn't work. Bless you. So these are polynomials of a higher degree. Again, it's a long list when we want to graph it. Why do we start by graphing it? To see what it is and why it looks the way it does. And then we'll look at word problems. Okay? So first we have to choose an odd degree. Once I understand how to graph the third, I will never have difficulties with the fifth, the seventh, the ninth, the 11th. Then we have to graph the even degree. If I understand the fourth, I will have no difficulties with the sixth and the 8th and the 10th and so on and so forth. So once we show, and like always, the first problem will take long, right? A long time. So let's choose. Would you like to start with an odd degree or with an even degree first? It doesn't matter. Okay, perfect. Let's start with an odd degree. Let me tell you where they are, and please choose. Odd degree polynomial functions. They are on page 2. Now, the method in the book, I don't have anything against it. What I have against it is the fact that they don't summarize the information in a table. This I don't like. The method is okay. But the fact that they don't summarize the information, they don't put it in a table so you can see what needs to be done and how to graph and so on and so forth, it makes no sense to me. Okay, so on page, I'll show you how to summarize the information. On page 378, from 41 through 64. Let's choose an odd degree. Degree 3 or 5 or 7. If you don't want to choose, I will. You agree? You okay. Thank you for the vote of confidence. Okay. Yes. I'm looking at 53. F of x equals 3x squared minus x to the third. Again, so please bear with me. It's going to be a long list. With quadratics, we had 8 steps. With this one, we have more steps. There is more involved. Okay? But we will have those 8 steps except the vertex. Never ever talk about the vertex except when we talk about the quadratic function. No other function has the vertex. Like no other function has a slope, but linear function. Okay, very good. So, first things first. I don't like it. Now I do. This is the correct function, not that. They're trying to trick us. You understand why. It has to be in descending order at all times. Perfect. First step is first step always for any function. What is it? Perfect. Always. I can't graph without finding a domain. I can't even think about it. And since it's a polynomial function, I should never think negative infinity to infinity. Step number 2. There is no shape here per se, okay? In the sense that max min, no. But you will see in a moment what when we get to that. Number 2, X intercepts. And I'm going to write something that we have never seen before. This is new. And their multiplicities. Multiplicities. What is this? I would like to go on the side and talk about multiplicities, and then we'll come back. So here's the explanation first. Explanation. And then we'll come back to our function. But let's suppose, because the x-intercepts, how are they determined? How do I determine x-intercepts? Always. Setting y equal to 0. Okay, so I'm going to make something up. X plus 1 to the third, x minus 4 squared, x in front, and 0. So this is our function. This is the y, and I want to set it equal to 0. Can anyone give us the degree? Careful, count, and tell me what is the degree on the left. So this is x to the first power. This is x to the third, and this is x squared.
X squared.
This is x to the first. This is x to the third, and this is x squared. 6 indeed. Degree is indeed 6. Is that clear to everyone?
No. Can you find it?
X times x to the third times x squared. Copy the base and add the exponents. 3 plus 2 plus 1 is 6. Is that better? Good. So how many solutions will you give? Yes, 6 solutions. So I'm expecting 6 solutions. First one. Equals. Very good. From the next one.
I'm not mentioning
Finding solutions using the zero product principle. If this is 0, then x is 0. If this is 0, I have 3 solutions here. And they're all the same.
1,
No, because 1 plus
3.
negative 1, of course. X equals negative 1, x equals negative 1, x equals negative 1. From here, 2 solutions. X equals, very good. I know you do. Everyone does, I'm sure. Okay, so then, what is the multiplicity of solution x equals 0? How many times does it appear in this equation? Once. What is the multiplicity of solution x equals negative 1? And what is the multiplicity of solution x equals 4? Excellent. 3 plus 2 plus 1 must equal
6. I mean, sorry. Oh, yeah. No. I'm sorry. What is 6?
So when we talk about multiplicities, we only refer to how many times does a solution appear in the equation y equals 0. Now here's my next question. Why? Okay, fantastic. X appears once, 0 appears once, negative 1 appears 3 times, and 4 appears twice. So what? But here is what happens to the graph of the function based on multiplicities. So, for odd multiplicity, for even multiplicity. What does it, odd and even mean? Okay, so this is a multiplicity that is odd, 1. This is a multiplicity that is 3. Well, because 3 and 1 are odd numbers, we call this odd multiplicity. But multiplicity equals 2 is an even multiplicity. So what does this say about the graph? Here's what it does. For any odd multiplicity, the function crosses. But if it's 1, it crosses like this. If it's 3, it crosses like this. At that point, there is only one point. M equals 3, multiplicity is 3 for negative 1. It's only one point, but it crosses slowly, not directly. For multiplicity 5, it will be even slower. Still only one point. But it will look like this, not like this, and not like this. So there is a lot of information about the graph coming from the multiplicities of these X intercepts. Okay, so all odd multiplicity are across. The function must cross there. What happens with the even multiplicity? We looked at an even multiplicity. How many solutions are here?
2.
And they're both 0. What does the function do when the multiplicity is even of a solution? Turns. So it's this. Of course, it can come from below. It doesn't have to have a minimum. It can have a maximum. Or is this. So this is multiplicity, and this is multiplicity. Exactly. And the flatter, the higher even multiplicity, the flatter the function would be at that point. So this is a turn. So every time a 0 or an x-intercept appears an odd number of times, the function will cross. at that point, but I don't know how. It's a straight cross, it's a slow cross, or a very slow cross. Every time a multiplicity or an x-intercept appears twice, four times, 6 times, you will always turn, the function will always turn there. But I don't know how. If it's a straight turn, or a flat turn, or even flatter. Okay, so this was the explanation about multiplicities. And now we can go back to our function. So one more time. What have we learned about multiplicities? That every time we determine x-intercepts, this is only for x-intercepts and nothing else. Only for x-intercepts and their multiplicities, nothing else. Okay, so we took an example. We look at an example with 6 solutions. And we found out that 0 as a solution appears once, -1 3 times, and 4 twice. So at 4, the function will look like this, because the multiplicity is 2. At -1, the function will look like this, because it's a multiplicity that is odd 3 times. It will look like this. And at 0, multiplicity 1, the function will look like this. You will have this kind of cross. Multiplicity 1, multiplicity 3, and multiplicity 2. Okay, so knowing all this, we're going to set this function equal to 0. What is its degree? So degree, careful, degree for this function. Very good. How many solutions? How many x-intercepts? Exactly. Very good. 3 or 3 solutions. So now we want y equals 0, which is -x cubed plus 3x squared equals 0. Now this is an equation. I can clean it up the way I like. However, I cannot divide by x squared, so don't try. We need 3 solutions, and we have to come up with 3 solutions. But I will definitely multiply both sides by -1, because I'm solving an equation, and I can dictate when I solve an equation, not when I plug in. So what do you recommend we do now? And you will say, the only thing you have to do at this point is to out x squared. Very good. Awesome. Good. And I'm ready for 3 solutions, because we established from the get-go that this equation has to have 3 solutions. How many times?
Twice.
Very good. X equals 0 twice. Multiplicity? 2. And x equals? 3. Multiplicity? That's it. Awesome. At this point, or you can start from the very beginning, we should get our table going. Here's our table. We'll put all the information we have so far in our table. Ready?
I thought it was, wait a minute, it's 3, so x equals 0, x equals 3.
X squared means x times x. X squared means x times x. So that's why we have 2 solutions here. X squared is x times x times x minus 3. Right? Remember x squared, right? Is that okay? So you're writing it as x times x times x minus 3. X equals 0 is the first solution. X equals 0 is the second solution. X equals 3 is the third solution. Is that better? Is that, maybe that was not the question. I apologize.
You can go with it. It's fine. I don't, everybody else gets it. I'm fine.
But which part is not clear? I want to go back.
I thought it was supposed to be 3 solutions.
Yes. 1, 2, 3.
Okay.
But 2 of them are 0.
Which I didn't know.
If you want to write it like this, that's fine too. but I still have to identify the multiplicity. So x equals 0 comes from the first one, x equals 0 comes from the second one, and x equals 3 comes from the third one. And we do have 3 solutions. 2 of them are 0 with multiplicity 2, and the third one is x equals 3 with multiplicity 1. Better? Okay, so let's see what we put in the table. Negative infinity to infinity, which is the domain. 0 is in the table, 3 is in the table. We just determined them. What do I write underneath 0 and 3 for the function value? But remember how we found them. Right, 0. Since x equals 0 has multiplicity 2, is that a cross or a turn? Very good. I'm going to write myself a note. Do not forget, it's a turn. At 3, what does the function do? Does it cross or does it turn? Exactly. It's a regular cross. I know it's 8:30. I know we're not going to finish, so let's stop. On Wednesday, we'll start this problem one more time from scratch because I don't like doing half